Hello class, this is the fifth and final example of related rates of change. At any time you can pause the video once again and give this question a go yourself. You will find that in this question there's going to be yet again new things that we may not have considered, but after seeing it being demonstrated, it'll be a skill that you can apply later on as well. So here we go. Sand is being poured onto a pile at a rate of 3 meter cube per minute. The pile maintains the shape of a cone with a semi-vertical angle of 45 degrees. Before we move even further, I'm going to stop and already try and figure out as much information as I can just from this first half of the question. Okay, so I want you to go ahead and try and figure out as much as you can. You can probably see there's already a clue here for you for what to do. It's actually best if you can draw a diagram representing this slightly more difficult example. So I hope that was enough time for you. You can pause and take some more time, but the diagram that you should have gotten is something like this. We have a cone where the radius, the base radius, is r, the height of the cone is h, and it says here the semi-vertical angle being 45. It's going to be this angle here, because that's a vertical angle, and semi meaning half. So half the vertical angle is 45 degrees. Had you placed it here, that's actually called the horizontal angle. So this is the graph, or the diagram I hope that you would have drawn. Let's actually try and take as much more information as we can from here. It says that the sand is being poured at a rate of 3 meters cubed per minute. Consider what this represents. Since that is the rate of change of volume per minute, we can represent that as dV, the change in volume, over dt, the change in time, equaling 3. So sand is being poured onto the top at 3 meters cubed per minute. Let's keep going here. Now, since we're working with volume, let's find the volume, or let's use the volume rather, of a cone. It's 1/3 pi r squared times h. And in case you're wondering, the volume of any pyramid-like shape is 1/3 times the area of the base of the pyramid, or in this case, a cone. So 1/3 area of the base times the height. Now, if you were to continue and try and work with this, consider what happens if you do dv on d something. We have two variables, r and h. So we're not quite at the level yet of having two different variables to differentiate. So we're going to have to try and figure something out so that we have one variable. Let's take a look at this 45 degrees. It isn't placed there just because. It definitely has to play a part in the question. So since we're working with r and h in relation to 45, that's actually going to be the opposite and the adjacent. That's going to be tan 45 equaling opposite over adjacent. Tan 45 is 1. So from here, if we multiply both sides by h, we get h is equal to r. Now from here, we can actually change this volume formula into one of two different ones. We get 1/3 pi r cubed, because h is now r, or we can get volume, put a little line, volume equaling 1/3 pi h cubed. So there are two possible formulas for the volume of this particular cone. Now, having done this question before, you can stop and try and find some more information just from this first half, but I hope you can see just how much information we were able to gather from just this small portion of the question. So let's move forward and try and find the answers to the remaining question. I'm going to draw a line just to make it clear that we're now looking for part A. So when it says, when the height of the pile is 2 meters. So we're being told now that the height of the pile is 2. Let's find the, also it says, calculate the rate of change of the height. So part A, our goal, now it says here we're looking for the rate of change of the height. So our goal is going to be the change in height, dh, over dt. So that is what we are looking for. Okay, it's going to be a little bit tricky now, because if you try and figure it out at this stage, you're going to encounter some difficulty. Oh, actually I just realized we forgot to do one more thing. Here we can find dv on dr. Differentiating, we just put the 3 in the front. 3 times a third is going to be, 3 over 3 is going to be 1. So we're left with pi r squared. And for this one we have dv on dh. Same thing, pi h squared. Sorry, I forgot to do that part. So let's move forward here now. So yeah, we're looking for dh on dt. In actual fact, there's enough information shown here to find exactly this, so I encourage you to pause and give this a go yourself. As I do this, you're going to see something new that you probably would not have considered. So now let's consider what we are given, or well, what we calculated. We have dv on dt equaling 3, which is good because we have dt here, so we're close already. So let's actually just plug that in for now. We have dv on dt. So now all we're left to find is something over dv. We need to cancel these two. In actual fact, we're looking for a dh on dt. So can you see anywhere where we have this? If you look very carefully, we have dv on dh. So let's actually use that. dv on dh, which was pi h squared. Now here's the point, here's the part where you would probably have not considered it here. This we can think of as if it were a fraction. If we were to take the reciprocal of this, we could flip this fraction. So we could get what we needed, dh over dv. Likewise, with this right-hand side, we can think of this as a fraction over 1. Because we took the reciprocal of the left-hand side, so we put it to the power of -1, we have to do the same thing on the right-hand side. So we're going to flip this fraction as well. This is going to be 1 over pi h squared. And now we have that dh on dv that we were looking for. So substituting all of this in, dh on dt is equal to dv on dt, which is 3, times dh on dv, which is what we just found here. That's going to be 1 on pi h squared. So all in all, dh on dt is 3 on pi h squared. Now remember, we're looking for the rate of change of the height when the height of the pile is 2 meters. So at this stage, all we're going to be doing now is let h equal 2. So the rate of change of the height, so dh on dt, is equal to 3 over, since I'm substituting 2 here, 2 squared is 4, 3 on 4 pi. Since h is in meters, because it's meters per minute, this is going to be meters per minute as well. And that there is part A. So the newest thing that you probably would have not considered is this last one here. You could actually take the reciprocal of that dv on dh. So I'll leave you to pause and try part B yourself. Part B, we're looking for the base area. Okay, I'll leave it at that. You can watch the solution to part B in the next in the next video, but you can give that a shot yourself now. So I hope to see you then. Best of luck.